Hello everyone. Welcome to this new lecture of digital image processing. And today we are going to discuss this unit first in the detail. And the kind of topics we are going to discuss here is very much important for the university point of view as well. So, for the AKTU students, the code is KEC071 and it can differ according to universities as well. So in the unit first, we are going to discuss overview, then application, then digital image representation, type of images, and the operations that we are going to use in DIP, then fundamental steps in DIP, and overview of digital image system, physical aspect of image acquisition, biological aspect also, and sampling and quantization techniques. After that, we have digital halftone process and then image storage and file format. So these are the kind of contents which we are going to discuss in this unit, right? So these can be the books can be referred to this DIP course, and this one is Raphael, and for S reader you can also refer. Okay. Now moving ahead, first of all, we have to know that what is digital image fundamentals, right? What do you mean by digital image? So the field of digital image processing refers to a processing digital images by mean of digital computer. So as we are using the name digital, that means we are going to use here a computer or computer methods to digitalize or to do the digitalization in the image, right? So digital image is composed of finite number of elements, each of which has a particular location and value. So we will be going to discuss this one further. So these elements are called picture elements, image elements, pixels. Pixel is a term used most widely to denote the elements of digital image, right? So the first thing comes here is pixel. So pixel is something that we use to denote the elements of the digital image, right? So an image is a 2D function that represent a measure of brightness or color of a viewed scene, right? One more thing I want to tell you, like the value of the pixel will represent the intensity, right? And it can be referred to as the gray level as well. So an image is defined as a 2D representation of a 3D view. An image may also be defined as a 2D function, and where x and y are spatial plane coordinates, and the amplitude of half at any pair coordinates is called intensity of the image. What that I have told you earlier as well. Suppose we are having this image, right? I'm just denoting it in the format of spatial coordinates. So if I just write here f of this would be 0 0, right? Let us suppose it is in the 0 column and 0th of row, right? So this one would be the first element, right? So this is our a kind of element and refers to as a pixel, right? Now the value of this element would be refers to as intensity, right? If f00 value is, we have suppose 5, right? So that means the 5 is the intensity of that pixel, right? It is denoting the amplitude of that particular location, right? And now we are moving to another topic, that is gray level. So the term gray level is used often to refer the intensity of monochrome image, as I have earlier told you, like uh, this intensity can also be referred to as gray level as well. Okay, so color images are formed by a combination of individual 2D images. For example, the RGB color system has a color image consists of three red, green, and blue individual component images, right? Basically, generally we use in our images, we have the three colors mainly, red, green, and blue, and after the combination of these three colors, we use to make the different colors as well, right? So for this reason, many of the techniques developed by for the monochrome images can be extended to color images by processing the three component images individually, right? Now in the xy coordinates, we have the continuous of amplitude, right? So converting such image to digital form requires that coordinates as well as the amplitude be digitalized, right? So for that, we are gonna use the sampling and quantization in the like further classes, right? Now application of digital image processing we are gonna discuss. So why we use a digital image processing, right? So the first advantage is biometrics. So biometrics authentication system is to recognize a person on the basis of physiological or behavioral trait. Fingerprint, face, DNA, these all kind of data can be very important for the biometric authentication, right? So forensics is based on the database information about the individuals. Forensic match the input data with the database to define the person identity, right? So when we just go to the Aadhaar center to make our Aadhaar, they generally used to take our data, right? The fingerprint, the eye scan, right? So after that, when we generally have the biometric authentication at the platform or in the airport terminals, they are they match our kind of identity with that Aadhaar database that we have earlier given to them, right? So after that we have factory automation. The factory automation is basically the plant automation in which the industrial image processing is often used for object identification and tasks performed to ensure complete monitoring and traceability. Right? Suppose we are having a kind of box which I have to place at particular location in the industry. So I can use there the DIP or digital image processing. I can make a tag over that and can put that box at a particular location, and that can be set in our kind of system that this particular box has been dispatched, or I have put that box at that particular location, right? So this is how we can use the factory automation as well. After that, remote sensing. So remote sensing, where satellites and other spacecrafts image acquired by satellites are useful in tracking of earth resources, geographical mapping, prediction of agriculture crops, urban growth and weather monitoring, and flood and fire control, and recognition and analysis of object containing images obtained from deep space probe missions, right? Then image transmission and storage applications, broadcast television, the teleconferencing, and then we have different kind of other satellite applications too, right? Then we have medical imaging. So in medical imaging, generally we have the X-rays, we have ultrasonic scanning, right? So in the document image processing, we also use the DIP. How, like, as you know, document image processing aims to create a paperless office by capturing the documents in the form of an image, right? Now defense and military applications, we can also use it. Then photography, in photography we generally use a DIP, because when we click any photograph, then we need to have the a blending, or we have to animate that kind of particular image if we want, right? So in that case we use the DIP as well, right? So now entertainment, in the internet entertainment purposes we can use it, like as with the availability of low cost cameras and internet, many applications such as facsimile image transmission, video conferencing, and image morphing are quite useful for personal as well as commercial purpose, right? Now moving ahead, we have the digital image representation, that how we generally represent the digital image, right? So as I have earlier told you, like image is a 2D representation of a 3D view, right? We cannot capture the kind of 3D view, right, on a particular page, right? So for that we generally draw the 2D representation of that 3D image, right? And image is a two-dimensional function, fxy, where x and y are spatial coordinates, right? And the amplitude of any pair is called the intensity or gray level of that image, right? So the image is a 2D function, right? This one is our intensity of that image. If I just suppose, which pixel is this, I have to write down f of x0 and y0, right? So this is the pixel element at this position, right? And the value of it is representing the intensity or gray level of that image, right? So as you can see, this is the bright level here, this one is the dark level. So generally, if I am having the value, suppose we have a binary image, right, which is in the form of 0 and 1. Suppose the value is 1 here and 0 here. So where the value is 0, it will generally refers to as a dark kind of area, right? And where the we have the 1 at particular position, that can be referred to as a bright image, right, or bright area. So an images are denoted by two-dimensional function, that is fxy, that I have earlier told you, and is represented by a spatial function. So spatial coordinates we generally say it, right? Then the value or amplitude of is positive scalar quantity whose physical meaning is determined by the source of the image. When an image is generated by the physical process, its values are proportional to energy radiated by the physical source, right? Now we have to just know the type of images. So classification of images are here. So images can be classified into the four types, that is attributes, color, dimensions and data types. So in the attributes we have to know that it is of two types, that is raster and vector. Then in color we have binary, gray level and true color and pseudo color. In dimension we have 2D and 3D. In data types we have signed integer, unsigned integer, float, logical and double, right? So these are the classification. We have to know that attribute, color, dimensions and data types. How you can learn it? ACDD, right? ACDD. You can learn it like this one. Attributes, color, dimension and data types. You all know dimension is of like 1D, 2D, 3D. So we have generally two types, 2D and 3D, right? And in color we can write gray level, gray scale, as gray is also a color. True color, pseudo color. Pseudo is like a false color. We generally do not have a kind of particular colorful image, right? So binary, I have already told you that 0 1 in the form of 0 1 we generally represent the binary image. Then raster and vector in the attributes, and data types we have float, logical, double, signed and unsigned integer, right? After that we have key stages in digital image processing. We have to just generally in this unit we must have to focus on this topic only. This one is very much important, that what are the key stages in the digital image processing. So first of all we must have to make a kind of like a knowledge base, right? Or you can make a box in the middle, and after that we have a problem domain, and image acquisition is the first step. Image enhancement is the second step. Image restoration, after that morphological processing, segmentation, object recognition, representation and description, and then image compression and color image processing, right? These are mainly our key stages in the digital image processing. These are our 9 stages, right? We have to focus only on the 5 stages in it. But generally when we make this kind of diagram, we must have to use these all 9 steps, right? But mainly we must have to focus on image acquisition, image enhancement, image restoration, segmentation and compression only, right? Now first of all we have to know that what is image acquisition, right? So it could be as simple as being given an image that is already in the digital form. Generally the image acquisition stage involves processing such as scaling, right? So what we generally do in the acquisition is we have particularly an image that is already in the digital form, but here we just involve the image acquisition to scale our image, right? Image enhancement is our second stage, that is it is among the simplest and most appealing areas of digital image processing. Generally in image enhancement what we do is we just increase the brightness or contrast, or modify the brightness or contrast, right? The idea behind this is to bring out the details that are obscured or simply to highlight certain features of interest and image. Image enhancement is a very subjective area of digital image processing, right? Now image restoration, as the name itself saying restore, that means there is some kind of loss or some kind of attenuation in the image, right? So it deals with improving the appearance of an image. It is an objective approach in the sense that restoration techniques tend to be based on mathematical or probabilistic models of image processing. Enhancement on the other hand is based on human subjective preferences regarding what constitutes a good enhancement result, right? So basically image restoration is used to restore the image from the from the noise or blur, right? After that we have color image processing. Color image processing, it is an area that is being gaining importance because of the use of digital images over the internet. Color images processing deal with the basically color models and their implementation in image processing application, right? So you can see this one is black and white image somehow looking like this, and this one is colorful image. So this is more detailable, right? We can see more details in it. Then wavelets and multi-resolution processing, foundation for representing images in various degrees of resolution, right? So in this one we can just check the image from the various angles or degrees, right? Then compression we have, that means as the name itself saying compressing, that means we are removing the redundant data in the compression, right? So it deals with the technique reducing the storage required to save an image or the bandwidth required to transmit it over the network. It has two major approaches: lossless compression and lossy compression. I will let you know in the fourth unit about it, right? Then morphological processing is that it deals with the tools for extracting image components that are useful in the representation and description of shape and boundary of the objects. It is majorly used in automated inspection application. As you can see here, the images are showing the kind of thumbprint or the fingerprints of of a person, right? So basically in this morphological processing we generally extract the information of the person, right, by the description of the shape and boundary of the object. So basically here we just have the deep survey of this boundary detailing, right? So this one is morphological processing. After this we come to next, that is our representation and description. So in the representation and description, it is always follows the output of segmentation step, that is raw pixel data constituting either the boundary of an image or points in the region itself. In either case, converting the data to form suitable for computer processing is necessary, right? So in this step we generally represent or describe the description of the image, right? uh, After that we have object recognition. So this can be a final step. So it is a process that assigns label to an object based on its descriptions. It is the last step of image processing, which use artificial intelligence of the software, right? So generally if we already having a kind of image, then using this AI tool we can recognize the object or image, right? So after this, we come to the fundamental steps in DIP. So what kind of things generally we have in the DIP? Suppose I'm having this source, like this is our sun, and this is our tree object, which is radiating a kind of like energy on the object. After that, using the sensor, suppose we are having a camera. Let's take an example of it. I'm having a tree first of all, right? This one is our object. Suppose it is a tree. Okay. After that, what we have is lens, right? I'm having this lens, right? After lens, what we have, I am having a digitizer, right? Now just take this example in the daily life. The tree is here and we are capturing the image using the mobile of lens of the mobile. So lens, after the lens we have a digitizer which converts the analog signal into the a digital signal, right? After that, I am having the digital image computer or DIP processor, we can say, right? So this one is processor. After that, we have display, or we say like hard copy we can also get, right? This one is our output image, right? So this one is our object. Then we have lens. Then we have digitizer, and then we have digital computer, or we generally say it as digital image processor. And then we have the output of the image, right? So this diagram is showing this one. Sensor is basically sensing the image, or we can say the sensor is photodiode, which is converting the light into the electrical signal, right? So the basic need of the sensor is that to convert the light energy into the electrical energy, right? Then digitizer is converting analog to digital signal, and digital computer is doing the digital image processing that we have earlier read in the above steps, right? The fundamental steps that we have already read. Then we have nature of image processing, the imaging system mode, reflective mode, emissive type of imaging, transmissive type imaging, video camera, thermal imaging, and X-ray imaging, right? Then we have components of image processing system. So computer we have image displays, we have mass storage, we have hard copy, we have specialized image processing hardware, image processing software, image sensors. So I have earlier told you that we at the end here we have the output image. So here we generally use this kind of things: image displays, mass storage we can use to store our data, or hard copy we can get of image. So this kind of thing we are going to discuss here. Image sensor is the two elements are required to acquire the digital image. This device that is sensitive to the energy radiated by the object. Digitizers for converting the output of the physical sensing device into the digital form, right? It is converting the uh, light energy into the electrical energy, right? Specialized image processing hardware is computer. It is general purpose computer and can range from a PC to a supercomputer, right? Software, it consists of the specialized modules that perform a specific task. A well-designed package also includes capability for the user to write code as a minimum utilizes the specialized module, right? Then we have mass storage. Storage can be used because as the pixel increases, the kind of image uh, data can be increased, right? It can be in the GB, it can be in the TV, right? Then we have image display. It can be of the LCD screen, right? Hard copy, we have printers. We can get the hard copy using the printers and heat sensitive devices, inkjet units and digital units. Networking, we have if I want to send data from one place to another place, the networking plays a very important role in that case, right? Then we have similarity between human eye and camera. Suppose I'm having this light source and object is here. I'm having this eye and this is our video camera, right? So using eye lens, the kind of images being formed in the brain, right? But using the video camera, the kind of image we get on the computer, right? One thing we have to know is brain is always read the inverted image, right? Now light source is getting reflected on the object. That is why we are able to see the object, right? So the light source is emitting lxy lambda and what we are getting is ixy lambda, right? So this kind of diagram can be formed in the human eye and camera similarity, right? Then sampling and quantization. Now this is the very much important part that we have to study. When we use the kind of digitizer in the digital image processing, we have a part that is digitizer. So in the digitizer, the main part is sampling and quantization, right? So sampling and quantization, as the name itself saying, sampling, that means the kind of image that we are getting using the lens on the sensor, it can be sampled in the various parts and then quantized into the different kind of digital amplitudes, right? So the output of MOS sensor is a continuous voltage waveform. Suppose this kind of thing we are getting, right? So what I have to do is I have to just sample this one, or sample, I have just cut down this kind of part. First of all, this is our sample of the image, and then to quantize it, I have just quantize it into the various amplitudes, right? So that it becomes simple for me to get the digital data from that image, right? So the output of MOS sensor in a continuous voltage waveform whose amplitude and spatial behavior are related to the physical phenomena being sensed. To create a digital image, we need to convert the continuous sense image data into the digital form. So this involves the sampling and quantization. So analog image we are getting, this one is our analog image, and then after the image sampling, we just forward it to the quantization, and then after that we will get the digital image. So this is basically the sampling and quantization technique. And the illumination source reflect the energy from a scene element, and the first function performed by the imaging system is to collect the incoming energy and focus it on the image plane, right? So to convert it in the digital form, we have to sample the function in both coordinates and in amplitude. Digitizing the coordinate values in sampling, digitizing the amplitude values is called quantization. So this is the very important thing. If you are digitizing the coordinate values, this is our sampling, right? And if you are digitizing the amplitude values, is our quantization, right? As I have earlier told you, like this is our kind of analog image, and if you are just digitizing this amplitudes, right? So this is our amplitude, this is our amplitude, right? If I'm just digitizing the amplitude, that is refers to the quantization. And if I'm referring, if I'm digitizing the coordinates that I'm using, right, this one, this is known as the sampling, right? After that we have digital half-tone process. This is very much important, which comes in exam with the topic like discuss something about digital half-tone process. So what it is, generally if I say like printers and display systems cannot produce all colors, definitely we cannot use the uh, old type of color in a printer or display system. So if the image are displayed only with a subset of available colors, the images are called partial tone or half tone images, right? Suppose I have earlier told you that we generally use the RGB, in the LEDs or LCD panels, right? Or LED panels that we have in the TV, right? So RGB is used to form the whole image, right? So these color combination can make the all colors, right? After that, we have this half toning is a technique used to produce the gray shades for bi-level devices such as printers. So half toning is a technique used to produce the gray shades for bi-level devices such as printers, right? So to produce the similar kind of images that we need, this process is used, that is half toning, right? So half toning techniques are used to create an illusion of continuous shades in the image by taking advantage of the human visual system, right? As our eyes cannot visualize all the different colors, then we have half toning algorithms produce gray tones and color tones by assuming that the image will be viewed at a distance. Right? The half toning algorithms produce gray tones and color tones by assuming that the image will be viewed at a distance and that the average color is printed paper result in a good visual appearance. So in overall thing, I would say like averaging of some subset of the colors we generally use in the digital halftone process so that the our image can be just visualized in a good condition, right? So dithering algorithms are very important category of half toning algorithms. Dithering is a quantization method where noise is added to the input signal before the signal is subjected to the quantization process. Right, based on the nature of the noise, the dithering algorithms can be categorized as random dithering and ordered right dithering or non-periodic dithering. Right. So random dithering is the number generates a random number in the range of 1 to 256 for a pixel. And if the pixel is greater than random number generated, the pixel is plotted as white. Otherwise, it is plotted as black pixel. So what it is saying is, it generates a random number in the range of 1 to 256, right, for a pixel. Now, if the pixel value is greater than the random number, right, if this it generated a number that is 3, suppose, right, and we already having the pixel which value is 5 and it is greater than this random pixel, that means the pixel is plotted as white because it is somehow showing the bright color, right? After that we have, if it is less than this, if we are having 2 which is less than 3, then definitely it would give us a black color, right? Then we have ordered dithering. It is based on the order of dots added. The pattern array is then used as a threshold mask for the given image, right? Then we have non-periodic dithering. So the idea behind this category of the algorithm is error dispersion. For each point, the closest color is obtained, right? So these are not that very much important, but we must have to focus like what is basically the halftone process. So halftone process is basically the averaging of some kind of subset of the color so that the image can be looked very good, right? So after that we have image storage and file format. So this is also a very much important part in this unit. So first of all, we must have to know that digital imaging system can store and transmit images definitely. So file format defines exactly how the image data is stored along with the image metadata in a file, right? So need for the file format, why we generally need this kind of file formatting? It may be necessary to transmit and image across the network to remote image system where the image may be accessed in a different environment of operating system, right? The differences in the operating system may cause interpretation mistakes. To avoid such mistakes, standard formats are necessary, right? What it is saying is like, suppose I am using window 11 and one is using the U12. So in this case, the kind of format can can have the interpretation mistakes. So to reduce this kind of thing, we must have a kind of file format that this is the particular file format we have, and we can open it in the any kind of system, right? Then role of compression in the file format. Most of the file formats provide image compression. Compression is of two types: lossless and lossy. Lossless compression reduce the size of the file using compression schemes that are completely reversible. That is, these compression schemes preserve the information. Medical applications often require the information to preserve in the file formats. Lossy compression method discard information that is not perceptible by the human visual system by discarding the redundant information that is present in this image, right? Lossless, as the name itself saying, that means there is no loss of data, right? During the image compression we just remove the redundancy bit, and after the decompression we just add on that that redundancy bit in that particular image, right? But in the lossy we just remove that particular information that is not very much important for us. So in this we can have the loss of some data, right? The selection of the file format is dictated by the requirements of the application, right? So the type of file format are GIG, that is graphics interchange format. So it uses the lossless compression technique called the Welch. That is the algorithm so that the quality of the image is very high. GIF can support 8-bit images and has 256 colors, that you can just 2 to the power 8, that is after that, the main advantage of this format are that the file is smaller in size, has good compression, and is good in displaying flat color areas. GIF also supports animation. So this is not GIG, this is the GIF, right? After that, we have JPEG, that is Joint Photographic Experts Group. JPG provides a facility of both lossy and lossless compression. This is very common format for storing and transmitting photographic images on the World Wide Web, right? So basically, what kind of images we use is JPEG group. So we must have to know the full form of it, right? The JPEG is the Joint Photographic Experts Group, right? Then PNG we have portable network graphic. If we want to portrait, if we want to just deliver a kind of photograph from one location to another, from using a kind of network, so in this case we use the PNG format. So PNG is specially designed for a web, and it generally uses the RGB images. It supports transparency and interlacing but not animation. One useful feature of PNG is its built-in text capabilities for indexing, allowing storage of text with the file itself, right? Then we have DCOM. DCOM is the digital image and communication, in which we have, this is very much popular format in the medical imaging. This file format contains image data and also metadata such as patient details, equipment, and acquisition details. So this kind of file format is very much important in the medical field. DCOM, that is digital imaging and communication, right? Then we have SVG, scalable vector graphics. This is the size in which we have the scalable to the size of the viewing window and adjust in the size and resolution, right, according to the window in which they are displayed, right? So scalable vector graphics is, suppose I'm using a 720 pixel of image, and if I just reduce the size of the window to the 540 pixel, then it would automatically be shifted to the 540. So this kind of image is our scalable vector graphics. As the name itself is saying scalable, that means we can scale this kind of image according to our own resolution, right? The advantage of SVG include small file size and the resolution independence, facility to include text labels, and description to assist research engines and complex animation, right? We can also include text labels into it and description to the uh, kind of image, right? Then we have TIFF, tagged image files, a file format in which we can do the image file header. We have IFD, that is image file directory entry, and image data. So suppose this is our image, so at the top we will be having this image file header. In between them we have all kind of image data, right? Then IFD we have, and the DE we have, right? So this is all about this DIP first unit. So we have covered this first unit, and we have discussed the most important topics that are like the key stages of DIP, why we need the DIP, the kind of half tone process we have already discussed, the kind of like uh, file formats we have discussed. So this is all about this first unit. So I hope you have understood it. So the video is already very lengthy, so I do not want to spread it or expand it much more. So thank you so much for joining this lecture, and if you are having any kind of doubt, please comment it out in the comment section, and please like and subscribe this channel. Thank you so much.